In this lesson, we're going to graph linear functions, and this is a review. This is a review lesson. You should know how to graph linear functions, but we're going to review it anyway. And we start with the vocabulary, which is also review vocabulary. And first of all, you will need to know what a function is, which I did not include here in the vocabulary, but you definitely need to know what a function is. And a function is a relation where where each value of x corresponds to only one value of y. So each value of x corresponding to only one value of y is what makes a function. And then we have a linear function. A linear function is obviously a function that creates a graph that is a straight line. The domain of the function of a function is the set of values of x. The range of a function is the set of the y values. So for example, if you have a simple linear equation, for example, y is equal to 2x minus 5. First of all, you do have to remember that this could be written using function notation. It could be written like this, such as f of x is equal to 2x minus 5, which means that f of x is just the same as y. It's just another way of writing y, so it's the same thing. Just using up here the function notation f of x, whereas here we're using y. So if we have this equation, which is a function, we could set up a table of values. For example, x and y. We could give, for example, the values of x of -2, let's say 1, and let's say 3. And then we could find the values of y. So what we do is we place in the x the value of the x, and then we find the value of y by simplifying, by doing the operations that we have here. So for example, we have 2 multiplied by the value of x, and then we subtract 5. So in this case, it would be 2, which is the original here, 2 multiplied by the value of x, which is -2, and then we subtract 5, so that is -4 minus 5, so the value of y is -9. And then we have, for the other one, we have x is equal to 1. The same thing would be 2 times 1 minus 5, and 2 times 1 is 2, minus 5 is -3. And then when x is equal to 3, we could have very similarly 2 multiplied by 3, and then we subtract 5, and 2 times 3 is 6, minus 5 is 1. So we have some values for the function, and one of the ways to graph is by graphing these points on the coordinate plane, let's say on a coordinate plane similar to the one that we have over here, and then we connect the points with the straight line. That's one method. It's like the most basic method of graphing linear equations, but we are not going to use that method here. But just to clarify what the domain and the range is, these values that you see over here are the values of x. That will be the domain. And the values that we see here are the values of y. That will be the range. So that's what the domain and the range is. So with that review, we're going to graph. In exercise number 1, we're going to graph the linear equation, which is a function. So we're graphing the linear function y is equal to 2x minus 3. For this one, we're going to use the slope and the y-intercept to graph. So we do need to remember that if you have an equation that is solved for y, so we say that it is in this format, which is the slope-intercept form of the linear equation, where the b is the y-intercept and the m is the slope. We always start by graphing the y-intercept, that's the first point that we put, and then we use the slope to get more points. So we look at the value of b and we find this value of b on the y-intercept. So for example, in this case, the value of b would be this value that we see here. That's b, and that's -3. So we're going to look on the y-axis, -3, which is down here. That's going to be our first point on the graph. And then we're going to look for the slope to get more points. The slope, we also need to remember that the slope tells us how to move either up, down, right, or left, depending on the number. So for example, if the number on the numerator is positive, we need to move up, and if it is negative, we move down. If the number on the denominator is positive, we move to the right. If it is negative, we move to the left. So in this case, the slope is here. It's in front of the x. So it is m equal to 2. And we always put 1. If it is an integer number, we put a 1 so that we get both movements horizontally and vertically. So because this is 2 over 1, 2 positive, 1 positive, we will be moving 2 units up and 1 to the right. So it's 2 units up and 1 to the right. So from our first point, which is the y-intercept, we move 2 units up and 1 to the right. We put a point over there. And then we repeat the same step to move 2 units up and 1 to the right, 2 units up and 1 to the right, and so on. So 2 units up and 1 to the right will give us first over there, and then we repeat the same step. We will give us the next point here. Then we repeat the same step, which will give us the next point here, and so on. 2 units up, 1 to the right. To the left, to the other side of the y-axis, we will go in the opposite direction, 2 units down and 1 to the left. And we have already a few points, and that's good enough to draw our graph. So we're going to draw a line using a ruler, a straight line passing through all these points. So make sure that the ruler is passing through all these points. I am going to put it here because I know that the next point is going to pass through that corner. So, and passing through all the points, it should look like that. We always put arrows on the ends because the line is infinite. And we can always write a name. This is y is equal to 2x minus 3. So that's it for graphing the line using the slope and the y-intercept. And now we have here the question that says, what is the domain of the function? So the domain are the values of x. The values of x are here on the x-axis. And as you can see, the arrows on both sides of the line shows that it is infinite. which means that this could extend forever on the left side and on the right side. That means we could actually be using all the numbers that are on the number line, all the real numbers. And we say real because we're not only using integer numbers such as, let's say, 1, 2, 3, 4, while also using decimal numbers such as, let's say, 1.5 or 2.5, 3.5, 2.9, and so on. For example, here will be 2.5, and there is a graph corresponding to that value of x, say 2.5. There is a graph that corresponds to that value of x, and we actually have here 1.5. So we're not only talking about integer numbers, we're also talking about decimals and fractions, so it's including all the real numbers. So the domain are all the real numbers. These R represents all the real numbers, or you could write it all the real numbers. Now, for the same reason, on the other question, the answer will be the same because it says what is the range of the function. Again, this line could go infinitely up and down. Therefore, the values of y, which is the range, the values of y that we use, could go up forever or down forever. So that means it includes all the numbers, all the real numbers. And I'm using both ways, but you only need to write it in one way. And that's it for graphing a linear equation or function. And number 2, which I'm not going to do it, just explaining very briefly, we know that f of x is the same as if we had a y over here, so it's the same. So it is y is equal to 3x plus 5. Again, if we use the slope and the y-intercept, we in this case have a y-intercept of positive 5, and we start here, and then we have a slope of negative 3 over 1, and in this case we will start here at positive 5, which is right here. There will be our first point, and then we will go 3 down and 1 to the right, because the negative on the numerator says down and the positive on the denominator says right. So 3 down, 1 to the right, 3 down, 1 to the right, and so on forever. And then you connect the points with a straight line. So I'm going to leave number 2 for you to practice. And we're going to number 3. Number 3 says graph the function f of x is equal to negative 2x plus 1 on the interval x is greater than or equal to negative 3 and less than 2. So it's the same type of equation that we did in number 1, that we also have in number 2. The only difference is that our values of x are restricted from negative 3 to 2, including the negative 3 because it says less than or equal, but not including the 2 because it just says less than. So if we quickly go back to inequalities, which we learned in the past semester, if you have, for example, an inequality that says x is greater than 3, and you graph it, this will be graphed on the number line. So this means that the solutions for this inequality are all the numbers greater than 3, but it's not equal to 3. So it's only what's greater to 3. And to show that, we leave an open circle at 3 because it does not include the 3, but anything that is bigger than 3, such as 3.1, would be a solution. So that is something that we do have to remember. If we have an equal, such as greater than or equal, less than or equal, we use a closed circle. But if we have a less than or greater than, we use an open circle, which means the number is included. Here it means the number is not included. So we're being asked to graph of this function only for these values of x. So we're only going to be graphing a piece of the graph. This graph is not going to be infinite. We're only going to be graphing the piece that starts from -3 and ends at 2. So we're going to start the same way. This has a slope of -2 over 1, so that means down and to the right, and a y-intercept of +1. We start over here at the y-intercept. So we have a +1 on the y-intercept right there, and then we go 1 down and 2 to the right, 1 down, 2 to the right, 1 down, 2 down, 1 to the right, 2 down, 1 to the right, 2 down, 1 to the right, and so on. So we will have our next point here, 2 down, 1 to the right, 2 down, 1 to the right, and so on. And on the other side, it would be 2 up, 1 to the left, 2 up, 1 to the left, 2 up, 1 to the left. But I don't want the whole thing that we see even here on the coordinate plane. We only want from -3 to 2, the values of x. So it's on the values of x on the x-axis. We only want to see the graph from x -3, which is here, to x +2, which is here, including the value at -3, not including +2. So at -3, we're going to draw a closed circle, here, and at 2, the graph will be passing down here, but it would be an open circle like that. And then we connect only from -3, from x -3 to x -2, +2, sorry, with the straight line. So we don't want anything else. I'm going to erase this point here because we don't need that one. We only want that piece. So it's not an infinite line, it's only as a piece of the line. So now we have a question that says, what is the domain of the function? Well, what is domain? Domain refers to the values of x, and the values of x that we are using to graph this line, or the graph, or the line is graphed only for these values of x. So that will be the domain. The domain are all the values of x between -3 and 2, including the -3, excluding the +2. That's the domain. Notice that when we say the numbers from -3 to 2, we're also including decimals, fractions. For example, at 0.5 5 negative, there is a graph over there that corresponds to that point. Let's say at 1.1 over here, there's a graph that corresponds over there. So it's not only integers, but also decimals and fractions, which means that is the real numbers between -3 and 2, including -3, excluding 2. So now what is the range? And the range are the y values. So we look at the graph. What are the values of y? On the y-axis, then, we see that the graph starts here, which is -3 on the y-axis, and goes all the way to here, which is +7. So the values of y that are used for this graph is -3 up to here, which is +7. And we're going to write in the same way that we have the domain, which is compound inequality, which was also learned in the last class, in the last semester, I would say. So the values of y go between -3 and 7. Look at the circle. Is it including the -3? No, because the circle is open, so it's greater than -3, and 7 is included, so it's less than or equal to 7. So the values of y are greater than -3 and less than or equal to +7. So that's the range. In number 4, I just want to very quickly review other types of lines. Not all of them are functions. In fact, everything that has to do with x equal to a number, such as part B and D, those are not functions. So these two over here, they're actually not functions. This one and this one. The other ones are functions, and we also need to remember that anything that says y equal to a number is a horizontal line, like that. If it says, for example, y equal to 2, so then it passes through the y-axis at 2 positive, and it goes horizontally through that point, which is +2. Like that. So that would be this would be the line y equal to 2. And these lines are functions because if you do the vertical line test, a vertical line test would pass through this graph but at only one point. So if you draw a vertical line, it only intersects the graph at one point, and that's a function. That means that this value of x that we have here corresponds to only this value of y, which is this one here, which is a 2. Now all the equations that have x equal to a number, let's say x equal to 2, or it could be negative as well. Those are going to be vertical lines passing through x at this number. So x on the x-axis, 2 is here, And so the line is going to pass vertically through that point. Like that. So this would be x is equal to 2. And any vertical line is not a function, because if you do the vertical line test, the only way that you can do it is by putting another vertical line on top of it, which means it's going to intersect with this graph at an infinite number of points. So it's more than one point. So if we do it very quickly here, y is equal to positive 4 is going to intersect at y in 4, and therefore it has to go horizontally, so it's like this. So this would be y equal to 4, and then we have x is equal to -3. This one is going to be intersecting the x-axis at -3, which is here, and it goes vertically, so it is going to be like this. Like that. And the name for this one is going to be x equal to -3. And then we have y is equal to -2, which is going to go through y at -2, and it has to go horizontally, so it looks like the blue line here. And then x is equal to 5, positive 5, so on the value on the x-axis we find 5, and it's going to be here, so it's going to pass vertically through 5, the same as the green line. So all the lines whose equation say y equal to a number are horizontal, like the blue line, and all the lines that say x equal to a number, they're vertical, like the green line. Horizontal lines are functions, vertical lines are not functions. And that will be it today for graphing linear functions on the coordinate plane.